Next relational set operators are the joins. Joins allow information to be intelligently combined from two or more tables. For the join, we have the following types. We have the natural join, equi-join, theta join, inner join, outer join, and for the outer join, we have the left outer join and the right outer join. Natural join links tables by selecting only the rows with common values in all their common attributes. It's a three-step process, and let's take a look at the following example. So, for example, we're given the customer table and the agent table. Step 1, we're going to get the product of the two tables. Step 2, we're only going to select only the common attributes with equal values. And step 3, we're going to perform project to eliminate the duplicates. Now, data join links tables using an inequality comparison operator, either less than, greater than, less than equal, or greater than equal. In our example earlier, if we're going to get the data join of that applied to the agent code where the agent code is less than equal to 125, this will be our result. Equi-join links tables on the basis of an equality condition that compares specified columns of each table. In our earlier example, if we're going to do equi-join between the customer and agent tables, the resulting table will have all of those match agent codes, and in the result, it might contain repeated columns. Take note that the column that you're going to specify in equi-join need not be the same name. Next, we have outer join. In outer join, matched pairs are retained and unmatched values in the other table are left null. For the outer join, we have left outer join and right outer join. In the left outer join, it yields all of the rows of the first table, including those that do not have a matching value in the second table. Let's take a look at the customer and agent tables as an example. If we're going to do left outer join for the customer and agent table, you will see that all of the records that you have on the left table are included in the results, even though they do not have a match in the right table. In this case, the agent code 421 doesn't have a match in the agent table, but it is still included in the results. Similarly, for the right outer join, it will yield all of the results in the second table, including those that do not have matching values in the first table. If we're going to apply customer right outer join agent, we're going to see that 3T3 doesn't have a corresponding result or corresponding record in the customer table, but it is included in the result because we use right outer join. Last, we have divide. Divide uses one double column table as a dividend and one single column table as a divisor. The output is a single column that contains all values from the second column of the dividend that are associated with every row in the divisor. Let's take for example this one. We have the original table P code and customer code, divide by the P code, and as we have said in the definition of divide, we're going to get all of those customer codes that are associated with each of the value that we have in the P code, meaning the customer codes 10030 and 12550 are in the result because both of them are associated with the codes 123456, 234567, and 567890 at the same time. Now let us define what we mean by data dictionary. Data dictionary is the description of all tables in the database created by the user and designer. The following is an example of a data dictionary. As you can see in this data dictionary, we have the table name, the attribute name, the contents, the type of data that you're going to store in that particular attribute, the format if there is any, the range of values that we are allowing for that column or for that attribute, if it is required or not, if it is a primary key or foreign key, and if it is a foreign key, what is the reference table. And as we have said, this is just an example. There are other formats that we may use or we may follow when we are creating our data dictionary. Next is System Catalog. System Catalog is a system data dictionary that describes all objects within the database. And getting a system catalog or creating a system catalog, we must avoid homonyms and synonyms to lessen confusion. Now, what do we mean by homonyms and synonyms? Homonyms is using the same name to label different attributes, while synonym is using different names for describing the same attribute. Now let's talk about relationships within the relational database. First, one-to-many. This one is the norm for relational databases, and most of the relational tables have the following relationship. Next is one-to-one, meaning we have one entity that can be related to only one other entity and vice versa. And lastly, we have many-to-many. If we have a many-to-many relationship, we need to break it down into two one-to-many relationships. It is implemented by creating a new entity in one-to-many relationships with the original entities. And that new entity in between the original two entities is what we call a composite entity, or sometimes a breach or associative entity. Having a composite entity helps avoid problems inherent to many relationships, and it includes the primary keys of tables to be linked. Here we have an example of the one-to-one relationship between professor and department. We know that the professor can chair only one department, and the department can only be chaired by a single professor or dean. If we have a many-to-many relationship, just like what we have in the student and class, we know that student can take many classes and a class can take many students. So in this case, we have a many-to-many relationship, and we need to break it down into two one-to-many relationships with an associative entity. And in this case, we are creating a breach entity and role in between the student and class, and we have, as you can see, a one-to-many relationship between those original entities to our breach entity. Now, the relational database facilitates control of data redundancies through use of foreign keys or the common attributes that are shared by the tables. To be controlled except the following circumstances. Sometimes data redundancy must be increased to make the database serve crucial information purposes. And sometimes data redundancy exists to preserve the historical accuracy of the data. Other than these very extreme circumstances, we do not want to have data redundancy in our tables. Next is indexes. Indexes are the orderly arrangement to logically access rows in a table. And we have what we call an index key, which is the index's reference point that leads to data location identified by the key. And the unique index, which is the index key, can only have only one pointer value associated with it. Now, each index is associated with only one table, but the index key can have multiple attributes. The concept of indexes, you can think of them as the index that we are using in a book, right? So if, for example, you would like to search for a certain word in a book, what you go to is the index at the back of the book. So you search for the word, and then the index will give you the location to which you can find that particular word in the pages. So that's also how indexes work in a database. So the index would work as the pointer to the location where your record is located. And lastly, we're going to discuss the CODS relational database rules. Rule number 1 is about information. All information in a relational database must be logically represented as column values and rows within tables. Rule number 2, guaranteed access. Every value in a table is guaranteed to be accessible through a combination of table name, primary key value, and column name. Rule number 3, systematic treatment of nulls. Nulls must be represented and treated in a systematic way, independent of data type. Rule number 4, dynamic online catalog based on the relational model. The metadata must be stored and managed as ordinary data, that is, in tables within the database. Such data must be available to authorized users using the standard database relational language. Rule number 5, comprehensive data sublanguage. The relational database may support many languages. However, it must support one well-defined declarative language as well as data definition, view definition, data manipulation, interactive and by program, integrity constraints, authorization, and transaction management, including the begin, commit, and rollback. Rule number 6, view updating. Every value in a table is guaranteed to be accessible through a combination of table name, primary key value, and column name. Rule number 7, high-level insert, update, and delete. The database must support set-level inserts, updates, and deletes. Rule number 8, physical data independence. application programs and ad hoc facilities are logically unaffected when physical access methods or storage structures are changed in our database. Rule number 9, logical data independence. Application programs and ad hoc facilities are logically unaffected when changes are made to the table structures that preserve the original table values. Rule number 10, integrity independence. All relational integrity constraints must be definable in the relational language and stored in the system catalog, not at the application level. Rule number 11, distribution independence. The end users and application programs are unaware of and unaffected by the data location. Rule number 12, it's non-subversion. If the system supports low-level access to the data, users must not be allowed to bypass the integrity rules of the database. And finally, rule number 13, rule 0. All preceding rules are based on the notion that to be considered relational, a database must use its relational facilities exclusively for management. In summary, we are able to discuss the following. We have introduced and explained what are the different types of keys. We have talked about the integrity rules, which are the entity integrity and referential integrity. We have talked about the relational set operators. And finally, we ended with the CODS relational database rules.